Good morning to all my YouTube viewers. Myself J. Das. In this video, I like to discuss about problems related to photoelectric effect. In the previous video, we have talked about its theoretical part, and there were few questions we have solved in that video. Now we will talk about problems on photoelectric effect. The purpose of this video is to enhance performance of the aspirants. Now someone may say that I have solved this problem and I know the problem, but in actual stage performance, for achievement at the stage performance, it may not be sufficient. You may see that you know the problem, but you are not able to solve under that competitive environment, the pressure what exists on that environment. So it requires to practice, it requires to develop certain amount of skill over the problem, over the chapter. It requires to know, requires to control over the chapter, control over the problem, and that is possible if you do threefold practices or 3 times practice, minimum 3 times, 4 times. It will be further better if you can go for few more steps. Now we know that without that we cannot get chance, because every problem has to solve below 60 seconds. That should be the objective of us. Let us start the subject. A 1000 watts power transmitter works at a frequency of 880 kilo per hour. The number of 880 kilohertz, the number of photons emitted per second is 4 choices given. One photon contains h nu joules of energy. So power is given 1000 divided by h nu will give number of photons per unit time, that will come 1.7 into 10 to the power 30 numbers per second. Next question, question number 2. Two identical photocathodes that has to note it, receive light of frequencies f1 and f2. If the velocities of photoelectrons having mass m coming out are v1 and v2 respectively, then there are choices, 4 choices are there. We have to get the suitable one. Now we know kinetic energy for maximum velocity, that is h nu minus w, that means half m v1 square equal to h f1 minus w. Here f1 means frequency of the incoming photons. Now in the similar manner, half m v2 square will be h f2 minus w, w is the work function. Difference between these two will give half within bracket v1 square minus v2 square, that is equal to h within bracket f1 minus f2, and then v1 square minus v2 square is twice h over m within bracket f1 minus v2. This relation is available in the answers, so answer B will be the choice. Now question number 3. Electromagnetic radiation of wavelength 3000 angstrom is incident on an isolated platinum surface of work function 6.3 electron volt. Due to the radiation, there are choices. Of course, we have to see the possible choice. Now, you have to see here the most important point, platinum surface, that is to be noted here, and energy required available for platinum surface which is having 3000 angstrom wavelength. So, Hc over 3000, that will give electron volt, that is coming 4.13 electron volt. This supply energy is not able to overcome even the work function which is given here 6.3 electron volt. It has to overcome that value, then only question of emission electron will take place. So, no photoelectric effect will take place here. Now, come to question number 4. Ultraviolet radiation of 6.2 electron volt falls on an aluminum surface, metal is aluminum and work function is 4.2 electron volt. The kinetic energy in joules of the fastest electrons emitted from here, choices are given. Now, you know kinetic energy equal to h nu minus w, h nu is given here, that is 6.2, which is coming from ultraviolet radiation photon, minus the work function will give the kinetic energy from this that is the question that you have to find out kinetic energy. Choice B is the answer. Question number 5. The threshold frequency for a certain photosensitive metal is nu suffix naught when it is illuminated by light of frequency twice nu naught. The stopping potential for photoelectric current is V naught. What will be the stopping potential when the same metal is illuminated by light of frequency, that is nu equal to 3 times nu naught. In the question it is found that we have taken higher frequency level. So, stopping potential will increase. Let us start. Work function for this will be h nu naught. Now, according to question, E V suffix naught equal to h, nu will be replaced by twice nu naught, because initial photon energy which is coming with frequency twice nu naught. H twice nu naught minus h nu naught, it will give us h nu naught. Now, for the another wavelength, incoming wavelength, that is 3 nu naught. That means, E V dash will be the stopping potential for this case, because stopping potential has to increase here. H within bracket 3 nu naught minus h nu naught will give us twice h nu naught. Now, comparing this one E V naught dash with E V naught, then you can see twice E V naught will come and V naught dash will be the new stopping potential will be twice the value of previous, that is twice V naught. That is the answer. Now, next question, question number 6. Photoelectric work function of a metal is 1 electron volt. Light of wavelength h equal to 3000 angstrom falls on it. The photoelectrons come out with maximum velocity. You have to see the velocity by using kinetic energy max equal to E minus W, h nu is minus W, from here V max is we know that 2 into h nu minus W divided by m, root under of all this. So, calculation can give us velocity, that is 1.09 into 10 to the power 6 meter per second. This sort of calculation we have to predict, because by practicing, by seeing that standard data, we have to keep few data in our mind, so that easily we can catch it. Now, come to question number 7. The graph between 1 by lambda and stopping potential V of 3 metals having work function phi 1, phi 2, phi 3 in an experiment of photoelectric effect is plotted as shown in the figure. Which of the following statements is are correct? Maybe more than one answer correct. There are 3 metals 1, 2, 3, V versus 1 by lambda is drawn here, that unit is nanometer to the power minus 1, values of 1 by lambda is given 0.001, 0.002, 0.004 for 3 metals. There are choices. The solution for this E V naught equal to H C by lambda minus phi. There is a standard equation. We can write V naught equal to H C over E into 1 by lambda minus phi by E. And from this we can say y equal to mx type plot. So, we can see the slope is H C over E. In the choice this answer is there. So, of course, this will be one of the answers. Now, tan theta will be H C, that gradient H C over E, and when V becomes 0 we can get value of 1 by lambda. Now, when V equal to 0, phi 1 becomes H C over lambda 1, phi 2 will become H C over lambda 2, and phi 3 will be H C over lambda 3. Now, from all these relations, we can see phi 1 is to phi 2 is to phi 3 will be H C over lambda 1 is proportional H C over lambda 2, proportional H C over lambda 3, H C is common for all. So, we can write 1 by lambda 1 is to 1 by lambda 2 is to 1 by lambda 3, that is 1 is to 2 is to 4 will be another answer. It has come. Now, 1 by lambda is in the diagram, it is given, that is 0.001. So, from here lambda 1 is available, that is 1000 nanometer, similarly lambda 2 500 nanometers, and lambda 3 250 nanometers, and in angstrom it will be just 10 times, that is 10,000, 5,000, 2,500 angstrom. One of the choice has been given here, that violet color light can eject photoelectrons from metal 2 and 3, 2 as well as 3, this point has to be noted. Violet color has a wavelength 4000 angstrom. Definitely this can this light can eject electron from metal 3, but it is not possible for metal 2, because for metal minimum wavelength required is 5000 angstroms. So, answer A and C is correct only. Now, come to question number 8. When a metal is illuminated by light of frequency f, the maximum kinetic energy of photoelectrons is 1.2 electron volt. When the frequency is increased by 50%, the maximum kinetic energy increased to 4.2 electron volt. What is the threshold frequency for this metal? So, as it is understood, particular metal is being dealt here. So, work function will remain same. According to questions, 1.2 kinetic energy equal to Hf minus W will be there. Another condition is given when frequency increase to 50% increase is there, 3 by 2 F will be the frequency, then 4.2 equal to H 3 by 2 frequency minus work function. Solving these two, work function we can find out 4.8 electron volt. And we know that work function equal to we can say H f naught will be the threshold frequency. So, f naught we can calculate out of it, that is 4.8 in electron volt over 6.63 into 10 minus 13, solving this, it can give us 1.16 into 10 to the power 15 hertz. Next question, a metal sphere is illuminated by light of two different wavelengths, 248 nanometer, 310 nanometer. Metal is same metal. The maximum speed of the photoelectrons corresponding to these wavelengths are U1 and U2. And these ratios are provided, U1 is to U2 is 2 is to 1 and H is equal to 1240 electron volt nanometer. The work function of the metal is nearly, we have to find out work function. So, it is understood that incoming radiation is 248 nanometers. So, it will contain 5 electron volt and energy for 310 nanometer it will have 4 electron volt. Now, here the work function is same because metal is same, kinetic energy expression is E minus W, K1 by K2 will be E1 minus W over E2 by W. Equal to K1 by K2 can be replaced by half mV1 square divided by half mV2 square from E1 square, it is E1 V1, anyhow I have taken V1 here. So, V1 by V2 whole square will be there. So, this ratio we can substitute 2 is to 1, from here we can get 4 by 1. Solving this we can find out work function here 11 by 3, that is approximately 3.7 electron volt. So, this answer is available in A. So, choice A will be answer. Thank you very much for good listening. Go through all these problems. We will give more number of problems because for JEE mains it is okay, but for JEE advanced and other exams maybe advanced level problems are required. In coming videos we will be giving all these. Next we will start which chapter? We will see which chapter can be given. If you like this, like it, share it and subscribe so that we can be motivated enough to go ahead with your support. Thank you very much.